if you hear somebody say, yeah, the material yielded, that's what it means. Hey guys, welcome to another video. Today we're going to be checking out the Hyatt Regency Walkway Collapse, which I honestly have never heard of. So this will be an interesting one to learn and see what went wrong. I'm not a civil or architectural engineer, but a lot of the same kind of principles of free body diagrams, dynamics, statics can apply in mechanical engineering, which is one of the main bread and butter courses of what we take for mechanical engineering. So if you guys are new here, I am a mechanical engineer, been in the field full-time almost 3 years, and I've interned at a couple different places before that. I'm a private pilot, and I'm big into 3D printing, so maybe some of you guys have that in common as well. Maybe you're an engineering student. So I like to learn stuff and give my take on it, and some maybe things I've picked up along the way that I can pass on to others. So if you're new here, welcome aboard, and excited to get into this. So let's get started.
At 7 p.m. on the 17th of July, 1981, more than 1,000 people were gathered in the atrium of the Hyatt Regency Kansas City Hotel for a tea dance when a structural failure occurred. 2 skywalks which crossed the lobby collapsed, crashing down onto the revelers below. The incident would cause the greatest loss of life from a structural collapse in American history, only ever to be superseded 20 years later by the destruction of New York City's World Trade Center.
There's a lot going on there. It's got even forklifts in there moving around. Looks like some cranes poking through the windows. Yeah, you would definitely need that. Jeez. This looks like the walkways went. I can't tell which way the walkways went. Maybe they were kind of diagonal from each other. Curious to see.
The Hyatt Regency Kansas City Hotel was part of the Crown Center complex, a suite of buildings owned by Hallmark Cards, consisting of both retail and residential space. The hotel stood 45 stories tall, with more than 700 rooms available for guests, as well as a grand ballroom and exhibition space. It was a popular venue, and the tea dances held there each weekend.
So we got one of the walkways here, and I'm wondering if these are the windows that the cranes were poking in. So it looks like we got one pretty close to that exterior wall, maybe?
And had swiftly become a phenomenon, drawing in ever-increasing crowds. People came to drink, dance, meet their friends, and enjoy an evening out on the town. By all accounts, the hotel was doing well. Construction had been completed just a year before, in 1980, and already it was a familiar landmark to many residents of, and visitors to, Kansas City. Of particular note was the lobby, an elegant, high-ceilinged space fitted out in metal, glass, and concrete, as well as...
Okay. This is a good shot. Okay, so back in the beginning there, it looks like we have 2 of them. Looks like there's a third up here even. So we got one walkway down here and one here. Maybe it's just this one that collapsed. I don't know. Let's back up to this picture right here. So it looks like both, honestly. Because this, unless they tore it down to get to this one. So it definitely looks like... Yeah, right here. So this one definitely collapsed. Okay. That's probably 1, 2, and some change. Probably 25 feet, if I'd guess. So that's a person. He's probably about 5-6 foot there. That's probably about 25 feet of height. So the walkway, if we wanted to, we could calculate how fast it was going when it hit the ground. So that would just be your kinematic equation. So you'll learn these in physics or any static dynamic class that you'll take. Where is it? Okay. So if we want to calculate that, you could do 1 × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ × 10⁻⁴ Yeah, it's this one. So V initial, so we're at an initial velocity of 0. You have, so basically 9.8 meters per second times the time it takes. And you could do the distance. Let's see here. Well, we don't know distance, so I don't know. It'd be kind of a guess. We'll see if it says it later on, and maybe we can go back and calculate
People
it.
often gathered on them to look down at the crowd below. They afforded an excellent view of the entire lobby, and of the live band providing the entertainment. Survivors of the disaster, which unfolded on the 17th of July 1981, report that there was little warning before the collapse occurred. At 7:05 p.m.
I'm gonna go back and look because I actually didn't. Oh, okay. Support wise, what are we looking at? Because I noticed in this shot here, you can see all the
5 p.m. Ordered on the 17th.
People here, what its loading looks like and what its support looks like. So we got a couple, what you want to call it, drops here of support.
And people often gathered on them of July 1980. At 7:05 p.m., several loud popping sounds were heard. Just seconds later, the 4th floor walkway failed.
4th floor, so it's more like 40 feet.
Collapsing straight downwards onto the 2nd floor walkway, which failed in turn.
Oh.
The combined mass of both walkways crashed down onto the densely packed crowd occupying the ground floor of the lobby.
So it was both of them.
Many victims who were caught in the collapse were killed instantly, but some did survive. They were left trapped in the mangled wreckage of the 2 walkways, pinned in place by concrete, glass and steel, gravely injured and inaccessible to rescuers. Worse still, the hotel's sprinkler system ruptured, flooding the ruined lobby with hundreds of gallons of water.
That's fun.
Having survived the collapse, several victims were now at risk of drowning. A rescue operation began, but was almost immediately stymied. Many of the pieces of concrete were too heavy or bulky to be moved by the equipment the fire and rescue service had on hand. Fire chiefs appealed to the construction community who, without hesitation, provided cranes, drills and other heavy lifting equipment to help rescuers reach those people still trapped in the rubble. Digging down to reach survivors was not a pleasant task.
Yeah, no kidding. So it looks like they got I-beam and a layer of concrete. I don't know. I'm not too on the up and up of how things are made in the walkway bridge world, but you know the basics. So that's interesting. I wonder. It must have been the pieces going to the ceiling in this shot. It must have been some kind of either connection, either connection point here or up here, or maybe they exceeded the tensile strength loading of the cable. If it's a cable, I don't really know at this point, but hopefully they let us know about that. That would be my guess. And then I wonder if one side broke and it kind of swung over and landed on this other one. So like these went twing twing, and it swung over and landed on that other walkway. That's what I'm curious about because it said it went down and smashed onto the 2nd floor walkway.
Further hampered by dust and debris. Furthermore, so densely packed was the rubble that in some cases the only way to reach survivors was by dismembering the dead bodies which blocked access to them. In a few cases, the only way to rescue someone was to perform an on-site amputation.
Just like that guy, I forget his name. What was that guy? He cut off his arm. Hiker cut off arm with Swiss Army knife to survive. Yeah, this probably. Aaron Ralston. I don't know if it was his name or not. Must have been. I think they remade a movie with what's his face? I don't remember. But anyhow, he cut us off his arm with a knife because it was trapped when he was climbing.
In total, 114 people were killed and 216 were injured in the incident.
Jeez.
Casualties were sent to nearly every available hospital in the area, while the dead were moved to a makeshift morgue in the hotel's exhibition area. The high number of casualties meant that almost everyone in the local area knew at least one victim. The psychic impact of the collapse was huge. An investigation was launched to find the cause, and its focus quickly narrowed to the construction of the walkways.
This is where we get into, if you guys have ever heard of the FE or PE exams, Fundamentals of Engineering, or I think it's Principles of Engineering, or Professional Engineer, or you're a professional engineer. This is more so important for civil engineers as they have sign-off power. Your title carries more weight. You're worth more money. If you have a PE, I think it's a license. But I took the FE for my after my mechanical when I graduated, just after, like a few days after. And it really doesn't serve any value other than you can put on your resume. It's a good thing to have. It's a lengthy test, about 5-6 hours at least, and it covers like all 4 years of your engineering degree. So you got thermodynamics, heat transfer, fluid dynamics, statics, yada yada yada. So this is where it comes down to, you got to know your crap, and if you're a PE, the responsibility is on you. So curious who this will fall on, personnel wise or company wise.
Analysis of the wreckage showed that a change had been made from the original plans.
Okay, yep, there's the stringers from, looks like that's so that's first floor, second floor, third floor. They said fourth floor, but it must have been third floor, so 30 feet.
Walkways for floors 2 and 4 were directly above one another.
Mm-hmm.
In the original plans, they depended from the same long hanger rods. But, in actual fact, these long rods had been switched out in each case, with 2 shorter rods.
Interesting design decision. I hope these are much larger in diameter to support this weight and this weight.
This seemingly innocuous switch had been made based on a proposal from the manufacturer of the steel rods. Long rods would have to be threaded along their full length, and would thus be easily damaged during installation. Replacing each long rod with 2 shorter rods would make things much easier to manage, they said, and so 2 rods were installed in each case.
So, fair point from the vendor. We go through this all the time with new parts, is you're like, I want this, and they'll be like, well, it might be better if you do it this way. So then that's on you to go back and test, as a mechanical engineer or whatever engineer, to go back and test and verify that, okay, yeah, that could work. So, seeming to allude to they did not do that here.
It was never taken into account that this would change the forces which acted upon the walkways.
Okay, taking a second to digest this here. Original design. Box beam. Support only the weight of the 4th floor. Okay, this must be the 4th floor walkway only. So he was right. I don't know, I'm confused. But whatever. As built. 4th floor walkway. Oh. Okay. Interesting. Yeah, so now you have a shear force in between these two things here. So let's get, okay, so it looks like here we'll just go with red and make it a little fatter. So we got the weight of this level pulling down here. And then you also have, which really is pull, this is in tension this direction, and then this is in tension this direction, so it's pulling apart, which makes sense. But now if we take this and look at it from this direction, so you have a force doing this and a force doing this. There's your beam. Do a little broken view there. So now you have a bending moment or a shear load right in this section of the beam right here. And I'm wondering if it buckled in that area. I don't think it would straight shear, but it may buckle, or you got some kind of bending moment going on here.
In this new configuration, the beams of the 4th floor walkway, where the hanger rods were attached, now had to bear twice the load they had originally been intended to hold.
Oh, yeah, okay, that makes sense. Okay, let's back up. So we got our I'm going to erase this. There we go. Okay, so what he's saying basically is all the load was originally transferred through this rod in tension, right? The only thing that this beam had to support was this level right here. This load of this level, whatever floor it was, that's all that this beam had to bear. So it was basically a simply supported beam. So you have your triangles on either end here, simply supported beam. And, you know, I have your load in here, and it's going to deform a certain amount, yada, yada, yada. So that's what there originally was. And now this beam is being asked to do this. Support the load while also basically, yeah, supporting twice the load, what he said. So instead of so we have only one floor being transferred, well, 2 floors, but it's being transferred through the beam instead of continuously supported by the rod. So the beam was never designed to hold 2 floors worth of weight. It would be transferred through the rod. That makes sense.
This, combined with the number of guests crowded on the walkway during the tea dance on the 17th of July, 1981, was what had precipitated the collapse. Analysis of the wreckage revealed that the nuts holding the walkway in place had pulled all the way through the box beams against which they had been secured.
Okay, so the material here yielded. This was on, which video is this? Oh, the Titanic, which very well received. Got a lot of views as of right now on it, and very excited about that one. But anyhow, go watch it. The yield curve. So for those who aren't familiar, yield, stress strain curve of steel. We'll just do steel. So there's a thing called a stress strain curve, and yeah, Young's modulus, right? So there's plastic deformation and elastic. So what's a good example right here that I have on hand? So plastic or elastic is I can pull this back and it springs back into position. I don't know if we can see that. So I can pull it so far, but it's always going to go back. But you know, if I crank this too far, it's going to like form a white mark here, and it's going to be stuck here. That's a plastic deformation. So at a certain point, you're going to have a spring rate, so to speak, up to the yield point. So the yield strength, that's the point at which it transfers from being able to spring back to going past where it will not return, you know, where it's going to not come back to where it's supposed to be. That's your yield, where if you hear somebody say, yeah, the material yielded, that's what it means. So in this scenario, you load people up, more people, more weight. Those nuts are getting closer to pulling through the C-channel box beam here, and they keep loading, and these, the tops of the flanges on the top here, they yielded at this point right here. So all that load was transferred basically to this radius joint here, and that part yielded. So that's what you'll do a lot of this stuff if you're mechanical or any kind of structural engineer relation for materials. So this is really interesting stuff, and it is good study on how things fail and how materials will react under certain loading conditions.
While this was the main factor in the collapse, it wasn't the only issue highlighted by the investigation.
And so also we see that it looks like one bar is intact. So this is another pointer to the fact that it was not designed to hold twice the amount of weight. It might have been designed, they might have designed it right to have a factor of safety of 2, to have a failure criteria that takes twice the amount of loading to make it fail. But then that switch put it in its worst case scenario where that didn't matter.
Numerous other safety violations and breaches of protocol were discovered. During the hotel's rapid construction, preliminary sketches had been used as though they were final signed-off drawings.
Nice.
And changes to the design had sometimes been confirmed by a quick phone call, rather than by the submission of revised plans.
Documentation is important. It can save you in a lot of situations. If there's anything that you're like, well, do I document it? Doesn't matter if it sits in your drawer for a year or whatever, you can always throw it away. But documenting stuff on how you did it, what your results were, how you got the results, what your test setup was, et cetera, is going to be huge in any profession. You can go into a review meeting with your boss or higher up engineers, and you need to support the reason why your design works or doesn't work, or what went wrong and why it went wrong, et cetera. So documentation is very important. That's one thing I would stress. If you're a student right now, work on your documentation and be extremely detailed. You can always get rid of information later. You can't make it up and hope to have something that passes people, because people are going to sniff that out, and it's not going to be pretty if you're the one leading the meeting.
The issue which caused the collapse of the walkways at the Hyatt Regency Kansas City Hotel was, according to the original designer, so obvious that a first-year engineering student could have spotted it. But it had gone unnoticed, with the various companies and contractors involved in the construction of the hotel all assuming that someone else had done the work of verifying designs and running calculations.
This is pretty much tit for tat for the Titan sub. The fact that the carbon fiber was used in the hull, there's more on that video if you want to go watch that. I'll just touch on it briefly. Fiber doesn't do well in compression. Buckles, a rope won't support you if you stand on it. It'll support you if you hang on it. And that's kind of the fundamental principle as to why the Titan sub failed, among with some other things, but yeah.
The disaster, and the hundreds of deaths which resulted from it, had been caused, in short, by poor communication and a laissez-faire attitude during a rushed construction project. The engineering firm, Jack D. Gillum and Associates, had been responsible for the original design and had approved the final drawings. In the aftermath of the disaster, they were stripped of their license to operate in 3 states, as well as their membership of the American Society of Civil Engineers.
So I am a member of ASME, American Society of Mechanical Engineers, and I did I was the president of the club at our university for 3 years, 4 years, something like that. I think 3 years. I don't know where I was going with that, but I wonder if they were stripped of their PE license too.
No criminal charges were pursued against the firm.
Really? Probably because they couldn't pin it on one certain person because there was no documentation, is my guess.
But owner Jack D. Gillum,
the owner of the firm, probably has his PE.
An engineer of note on the project, was haunted by the disaster for the rest of his life. He spent his remaining years lecturing and speaking about his involvement, in the hope that the story would scare young engineers out of making the same mistakes that he and his company did.
And he may not have been fully aware of the entirety of the situation. Not that that's an excuse, but he should be peer reviewing the designs and everything. So curious to see how much involvement he had. But he did a good thing then. He basically scared the death out of people to make sure you do your homework. It's a good thing because that happens, and the Titan sub happens, and all the other engineering things happen. Fails.
More than 300 civil suits were brought against those involved in the construction and management of the hotel. These lawsuits yielded billions of dollars in compensation.
I love this animation, or this little cartoon. It's pretty hard to see. Let's do snipping tool here again. Do a new one. See if we can kind of zoom in on this. So this is, yeah. So basically, it's not necessarily, it's the beam that failed, but it is this pulling through the beam. So back to, let's just draw it here. There we go. So those flanges were taking, yes, okay, so that's the whole thing, if you haven't got it yet. If you have just the rod supporting both all of the weight of everything. Okay, let me just draw it. Okay, so you got your C channel here. So this is we'll just say this is meant to hold 10,000 pounds with one single rod going through it. And then down here you have the other beam, which is also meant to hold 10,000 pounds on the beam. So these little flanges right here, let's change our color. I don't know, blue seems nice. These flanges right here will not buckle if you got 10,000 pounds on it. Maybe that has a 1.5 factor of safety on it. So maybe it's rated for 15,000 pounds, let's say, in theory. So what happened then is they basically loaded it twice. So you have your rod coming down, and then this is kind of a section view of it. So if we section it right here, and then we also section it right here at the next intersection, we can see, I'll switch colors to make it easy here. We'll also get the secondary loading. So along this same, both these flanges are being asked to hold 20,000 pounds when they're rated for 15, basically. That's what happened. These flanges here. And then they just yielded inwards, and you lost a walkway. It went right through. Okay, it's making a lot more sense to me now. Hopefully it's making sense to you guys.
A large portion of which was set aside for charitable causes to help the Kansas City community heal and move forward in the wake of the disaster. Even when agreeing to pay out compensation, everyone connected with the case denied all legal responsibility. Numerous changes were made in the fields of civil engineering and construction in the wake of the disaster. The collapse was international news.
Jeez.
In countries around the world, the curriculum for engineering students was completely overhauled.
It's the thing, when you have people involved, there's a lot more regulation for a reason. And, you know, for something you can just go take out in the street and blow up or start whatever you want to do, there's a lot less regulation to get something like that to work.
With a new emphasis on responsibility and safety. Standards were raised and trade manuals revised. With a new emphasis on responsibility and safety. Standards were raised and trade manuals revised.
So looking at these here, points B and C, The dead load prior to collapse averaged 17.8 kilofoot. Okay, where was I? So 17,800 kilo. I think that's an L pounds per walkway span. This is approximately 8% higher than nominal dead load. So it's only 8% higher than maybe its max rated load. Or yeah, but then it's loaded double, like we talked about with the beams, with the double loading on those flanges and the box beams. And then dynamic loading looked like they said was not a major factor in comparison to the static loading, especially on the box beams. But maybe a little bit of bounce, from some resonance could have really started to cave those flanges in before that thing pulled through.
The walkway collapse remains, to this day, a sobering case study for budding engineers, one which underlines very clearly the importance of good communication and adherence to protocol. A memorial, dedicated in 2015, now stands in Hospital Hill Park, close to the hotel, which itself has been entirely restored and refurbished.
I wonder what this is supposed to be. I don't know. Let me know in the comments if you know what it is.
The two collapsed walkways which once crossed the lobby have now been replaced by just one walkway.
Looks really nice.
Supported by pillars rather than hanger rods.
Probably for public perception. I almost guarantee that's why they did pillars. So then the public can't say, "Oh, well, you did it again. You didn't learn from your mistakes." So, yeah. Could have been a bigger walkway too. The current one could be. Not sure. So maybe that's why they had to do pillars. In addition to that, maybe the roof didn't have enough load-bearing capability to suspend it. So who knows?
And the hotel has been renamed. It is now known as the Sheraton Kansas City at Crown Center. Thanks to the sweeping changes which took place in the wake of the disaster, it has been described as one of the safest buildings in the country.
Okay.
The legacy of the Hyatt Regency Walkway Collapse is one of pain and trauma. But it is also a legacy of learning. Just as the renewed and
Oh, okay. I've had this wrong the whole time. Duh. I thought this one swung over and landed on this. No, it was double stacked. Okay, that makes more sense. I don't know why I was thinking that the whole time.
constructed hotel is safer than the old Hyatt Regency, so too are other buildings the world over.
Yep.
The lessons learned on the 17th of July 1981 were excruciatingly painful. But they were lessons, at least, that stuck.
That's an unfortunate part of some things is we learn by our mistakes. Oh, it's about anything in life. You learn by your mistakes. Let's see if there's anything left here. Yeah, so unfortunately, the disasters we learn a lot from, because when things go right, you don't really learn anything from them necessarily. You don't learn what you don't learn what you don't know, if that makes sense. So failure is good when it's in a controlled environment, and where testing failure is a good thing, rather, which this did not go through necessarily. And or like the Titan sub, where it didn't really go through any testing either, which I thought was pretty wild. So very interesting. It's the little things that can get you. You have to cross your T's and dot your I's, and that's the biggest thing in engineering, is being able to look at things and does it make sense? Does it check out mathematically? Have other people look at it other than yourself, get their feedback, be willing to listen to feedback, and be open about it. And ultimately, if your design's right, it shouldn't be able to be torn down really a whole lot at all. So, cool. Well, I learned a lot. Hope you guys learned a lot as well. If If you guys wouldn't mind dropping a like or a sub below, that would mean the world to me. Really trying to grow this channel. Really excited about it. So looking forward to seeing how you guys liked the video, and looking forward to the next one. And I'll see you guys then. Peace.